This is real man. This is charging, scaling.
Yeah. Okay. So that means this. Alright, so let's start again. The following two functions are given. F of x is equal to negative 3x plus 1, and g of x is equal to a times half to the power x minus 1. So 7.1.1 says, it is given that the function of g can also be written as g of x is equal to half to the power x minus 1 minus 1. And so the question is, determine the value of a. Okay, so let's look at this again. The following two functions are given. All right, so this is a grade 10 sort of like type questions. Okay. Alright, sorry, I just had to share that live again. Okay, so the following two functions are given. Let's just do this again. The following two functions are given. F of x is equal to negative 3x plus 1, and g of x is equal to a times half to the power x minus 1. I repeat, the following two functions are given. F of x is equal to negative 3x plus 1, and g of x is equal to a times half to the power x minus 1. So if you can look at this first and foremost, this function f of x, what type of function is this? Okay, we have four types of functions. We have a straight line function in grade 10, we have a parabola or quadratic function, we have a hyperbola function, and then last but not least, we have an exponential function. So this f of x is equal to negative 3x plus 1. What type of function form is this? Okay, can anyone tell me what type of function form is this? Is this linear? Is this linear or straight line? Is it exponential function? Is it hyperbola? Or is it quadratic or parabola function? Which one is this function? Okay, anyone care to let me know very quickly what type of function is this? Okay, we got Straight Dimples and Sihle Lucy going ahead and telling us this is a straight line function, and they're 100% correct, guys, that this is a straight line function because it has the form y is equal to mx plus c, or maybe some people may know it as y is equal to ax plus 2. And so we can see that our m or a value is negative 3, and then our q or c value is positive 1. So this is a straight line function. Straight Dimples is 100% correct. Together with Sihle Lucy, we can give them an amazing resounding round of applause. F of x is equal to negative 3x plus 1. And remember, f of x just means y, right? That's what f of x stands for. It's just functional notation which that they can come and join in. X is equal to a times half to the power x minus 1. What type of function, guys, is this? All right, we have a missing f, all right, which is not in as a number yet, but we will get there. So what type of function is this, guys? What type of function? I will. No problem, go ahead, please go and study. What type of function is this, guys? G of x is equal to a times half to the power x minus 1. exponential, hyperbola, parabola, or straight line? What type of function is this? Okay. Okay, I'm waiting very patiently. What type of function is this? Straight line, hyperbola, parabola, exponential? Which function is this? Is it, guys? What form do we have here? Okay, Sihlelusi is like on the roll. Very true. This is exponential function. Okay, and the form, guys, that we know the exponential function is ab to the power x plus q. Okay, please, guys, ab to the power x. Remember that the form of an exponential function has the exponent variable is x, right? So I hope you guys can distinguish. See the straight line function, ax plus q. The x variable has an exponent of 1 that we cannot see, and the variable x is in the numerator. Okay, so it's very different. Okay, so it's very different. So you can see the variable x in the numerator, okay, and it has the exponent 1, whereas here our exponential function has a variable x which is in the exponent itself. Okay, so yes, ab, all right, you can see the a there. We don't know what a is yet. We have half, which stands for the b. We have the x exponent, which is the x variable, which basically shows you that this is truly your exponential function, and then the q value there, which is in this case -1. All right. Aura, I do not only do grade 10, I do other grades, but just that at this present moment I'm doing grade 10 functions. Okay, which grade are you in and why are you asking? Okay, guys, so these are the following two functions that are given. All right, so let's look at the question. 7.1.1 says it is given that the function of g, okay, this function, this one, the function of g can also be written as g of x is equal to half to the power x minus 1 minus 1. So then the question is, determine the value of a. Okay, so we're supposed to determine the value of what? Of a. Right, so like I said, if you look at the original function, okay, so the a here, the a value, right, g of x equal to a half to the power x minus 1. Now we are told that this function, it is given that the function of g can also be written as g of x is equal to half to the power x minus 1 minus 1. And what they want us to find is the value of a. Okay, so if we look at this form of the function, right? Okay, let's just come down here so that we can have some writing space. So we were told g of x is equal to a half to the power x minus 1. But then in the question statement, it's saying that it is given that the function of g can also be written as g of x is equal to half to the power x minus 1 minus 1. So let's come down here and write the form which they are saying this g of x can be expressed as. So g of x is equal to half to the power what? X minus 1 minus 1. So guys, what do you see here? All right, what do you see here? They are saying this form can also be expressed like this. All right, so how can we relate this form and that form? Okay, so I'm sure what you can see here is that with this function we can use the laws of exponents. All right, and we can do the following: half to the power x times half to the power negative 1. Okay, and I'm sure you guys can understand why I'm doing this. Okay, so in other words, we can split, okay, half to the power x times half to the power negative 1. And then obviously there's the minus 1 that we have there, which is basically the constant there. Okay, so this negative 1 is still in place. Okay, now if you look at this form and the form where we did not have the a, I'm sure you guys can see that this half to the power x, we can still have it being in the same position that it was, and then this half to the power negative 1 can come before the half to the power x. So in other words, g of x is equal to half to the power x times half to the power negative 1. So let's come and write this in this state. Why can we do this? It's because, remember, this times that. Multiplication is commutative. In other words, we could write this first, write this last, or write this last, write this first. So we can swap it around. It doesn't matter because it's multiply. This is me like saying that a times b is the same thing as b times a, because multiplication is commutative, they say. That's the commutative property of multiplication. The order in which you place the a and the b doesn't really matter. Oh, there goes my network. Guys, my network is not... Okay, I hope... Just let me know in the comment section how's the network going, okay? Okay. Remember, we want the value of a, alright? And I think we can get it down to an actual value, alright? The value of a. After all, it's 2 marks, this question. Now, if we express half to the power negative 1, we can rewrite this as 2 to the power 1. A half can be written as half to the power negative 1 times another negative 1. Okay, remember that half can be written as 2 to the power negative 1, right? Half can be written as 2 to the power negative 1, which is also raised to this negative 1 that's outside there. Then that's half to the power x minus 1. Now you remember that in the laws of exponents, these two exponents can be multiplied to each other. There's this law in the laws of exponents that goes like this, that if a is raised to a certain exponent and that exponent is raised to an external exponent, what we do is just simply do what? Multiply the exponents. Okay. And then just something else as well. 1 over a is equal to a to the power negative 1. Okay, so that's where I'm getting the half being written as 2 to the power negative 1. There's a law that says 1 over a particular base can be written as a, all right, meaning you change the position of the a to the numerator, and then the exponent that was positive obviously will become negative because there's a positive 1 that's an exponent that you cannot see there for a. Alright, so that's why we write 1 over a as a to the power negative 1. It's the same thing as saying 1 over a squared can be written as a to the power negative 2. Okay, the a changes position, and then the exponent that is positive becomes negative. I hope that makes sense. Not that guy gags. Like I said, the half is written as 2 to the power negative 1. Okay, hang on there, not guy gags, just hang on there. So remember, the question is saying we need to determine the value of a. Okay, we want this guy here. Okay, and the a is coming before half to the power x. So what did we just do here? Okay, we were told that g of x can be expressed like this, half to the power x minus 1 minus 1. So what we've just done is we've taken the g of x equal to half to the power x minus 1 minus this one. We split half to the power x and rewrote half to the power x minus 1 as half to the power x times half to the power negative 1. Then what did we do? We swapped around. We wrote the half to the power negative 1 first, followed times by half to the power x, okay, which doesn't change anything fundamentally, minus 1. Then what did we do with this half? We wrote it as 2 to the power negative 1. We wrote it as the negative exponent. raised to the power negative 1, and then you know that negative 1 times negative 1 gives you a positive. So what we have, guys, is this. This is g of x. Okay? This is g of x. Okay? So our a value is actually equal to what? To 2. That's what the value of a is. Okay? So this a that we've been looking for, all right, is actually equal to what? To 2. Okay? I hope it makes sense, guys. I hope it makes sense. Yes, Aura, do grade 11. Definitely do grade 11. Okay, so there it is. That's the value of a. A is equal to 2. Okay, I hope that makes sense, because as I said, okay, the question said the following two functions are given, f of x and g of x. In g of x, we did not have a, all right, but we had a times half to the power x minus 1. Then in the question it says it is given that the function of g can also, keyword, can also be written as what? G of x is equal to half, please take note, half to the power x minus 1 in the exponent, minus this one, which is a constant. Determine the value of a. Remember, a was here, times the half to the power x, and g of x, we were told, can be written in this form as well. Half to the power x minus 1 minus 1. So what did we do? We took this form and we split it apart. Half to the power x times half to the power negative 1. Remember, me doing this is like law number 1 of exponents. Law number 1 says when you're multiplying same bases, so we have half and half, which we are multiplying. If bases are the same and we are multiplying, what do we do to the exponents? We add them. So this would be like saying x plus minus 1. And we know that x plus minus 1 gives us x minus 1 there. So this is me doing the reverse of law number 1. Okay. And by that I mean this. This is like the reverse. Okay. So I'm taking this and I'm expressing it as that. Okay. Then 2. This half, what did I do with it? I wrote it as a negative exponent. Where does that come from? It comes from when this thing that says when you have a fraction 1 over a certain base variable, you can write that very same base not in the denominator but in the numerator, but then the exponent will change sign from positive to negative the minute it goes to the numerator. So that's why it's a to the power negative 1. It's the same thing as saying 1 over a squared can be written as a to the power negative 2. The a changes position from the denominator to the numerator, and the exponent becomes negative. So this is what I did with half. I wrote it as 2 to the power negative 1. Okay, but then remember there's a negative 1 exponent, so what happens is that we multiply those two exponents to remove the bracket, and this is coming from this law of exponents. A to the power m raised to the power n, you can multiply the exponents in order to basically evaluate this exponent. So it's a to the power m times n. So what's negative 1 times negative 1? We know that it is positive, so we are left with positive 2. So this positive 2 is actually the a value that was missing that we were looking for. So a is actually equal to 2. Okay, hope now you understand, guys, and that it makes sense. Okay, in the same way, someone else could have taken that half to the power negative 1 and actually just simply did this. Taken the 1 to the denominator, taken the 2 to the numerator. And then what happens is that that exponent sign changes from negative to positive. That's another embedded law that we learn for exponents. I'm sure you guys saw this, man, when you did exponents, that if you have a fraction and there's a negative exponent, you can rewrite this as b over a, and then what happens to the exponent that's outside? It becomes positive and no longer negative. You just swap around the numerator and the denominator, and then the exponent on the outside changes to positive. So I'm saying you could have done the same thing here. This 1 over 2 becomes 2 over 1, which is basically 2, and then that exponent changes to positive. So that's how you get this positive 2. That's just another way of looking at how we would get this value that we have here, which is our A value. Okay, I feel like I've over explained that. I hope it makes sense, guys. I hope we're good. Any questions? Anyone in the comment section was like, serious questions? Are we good? Are we clear? Can I move on to the next question then? Okay, not that guy says we good. Aura, you need some help with paper 2 for grade 11. Okay. Okay, when are you writing, Aura? If I may ask. Okay, I can move on, Lucy. Okay, let's go. Next question. Give the range of the function g. Give the range of the function g. Okay, now that's the second question. Give the range. Do we all know what range is from at least what we've been speaking about even yesterday? Because I think I explained what range is, but maybe because of the network, maybe you guys didn't hear it. But do we all understand what the range of a function is? And can we answer the question? If the function that we are given is actually g of x is equal to 2, remember, half to the power x minus 1. We now have the full function of g. It's g of x is equal to 2 half to the power x minus 1. Can you guys give me what the range of this function is? Okay, not that guy X was all too happy to comment in the comment section and say y is an element of minus 1 to infinity. So I'm just going to write not that guy's Geg's answer, so that if there are any other answers, I will be more than happy to also entertain those answers as well. Not that guy Geg says it's y is an element, and please take note of his brackets as he indicates the answer, writing next week Friday. Okay, yeah. When would you like for me to have a session? On which day of the week would you like for me to have a session of paper 2 specifically, so that I can do a general session for paper 2, and then maybe I can have an evening slot where I can do that for you guys, or you comment for me. Mbali, was that a comment as well? Are you agreeing with not that guy as far as the range is concerned? Okay, are we all agreeing there that the range? Okay, remember guys, what the range is the possible y values where the function exists, possible y values where the function exists. And remember, I said we look at that range from the bottom to top. Okay, when we look at that range, yeah, so it's from bottom to the top. Yeah, so it's not up to down, it's from the bottom, meaning down there, from down there to the top. Please guys, right? Because remember, from down there for y, that's where the negative values are. And okay, so I hope you understand there. Okay, Friday this week. All right, Aura, I've got you there. If you need me to have an earlier session, Aura, you're more than okay to request that. Okay, but I've your request has been noted. I've duly noted it. So let's say 8 o'clock on Friday. So 8 p.m. on Friday, I'll be doing, I'm just noting it here, paper 2. And then topics, maybe you can even send me an inbox there. You can message me on the side and just let me know what specific things you'd like for us to cover on that specific day. Okay. All right, let's back here to the possible y values where the function exists from bottom to the top. Okay, so y is an element of -1 to infinity. Guys, please take note that this function, first and foremost, I hope we understand that if we can remember, we all said yesterday that when the a value is greater than 0, then it means that this function can be found above the asymptote. Okay? The function can be found above the asymptote. Thank you so much, Trillionaire, for that. Heart me. The function can be found above the asymptote. If the a value is greater than 0, in this case 2, all right, is actually greater than 0, then the function is found above the asymptote. What helps us locate the asymptote? It's this value. So y is equal to -1 is our equation of the asymptote. All right. So in other words, if we were to roughly, have an indication of this function, it's a function that's above the asymptote and it's in this direction. Okay. I just want to remind you guys, why do I say that? Okay. Yesterday, when we had our live session, if you remember very well, when I did exponential functions. Thank you so much, Trillian. I really appreciate it. Wow, it's so kind. Okay, if you remember very well, guys, when we did the exponential function, y is equal to ab to the power x plus q. Okay, we spoke about a, how the a value and the b value together help us to understand the shape and the position of our function. So remember, when a is greater than 0, we say that the function is found above the asymptote. So remember, our a value in this particular function for g of x is 2, and it is greater than 0. And if you remember the two shapes that we can expect or anticipate depending on b, if b is greater than 1, but at the same time a is greater than 0, then our function will be above the asymptote, okay? And it will be this shape, increasing function. But if that b is between 0 and 1, then it's a decreasing function, but it's also found above the asymptote. So if we are going to now refer to the range, that means this function is found above this horizontal asymptote. Y is equal to whatever it is. It's found above, all right? It's not found on this line, because remember, the asymptote is a boundary line where the function does not exist, okay? So we cannot include the value of the asymptote in our writing of the range. So the function is found here above the asymptote. So it's all the way above the asymptote. Not on the asymptote, but above the asymptote. So let's go back now. If I'm going to write down, guys, the range of this particular function, let me just rewrite the function. It's g of x is equal to 2/2 to the power x minus 1. So we know what the asymptote is. Now we understand, okay, this q value gives us the equation of the asymptote. Y is equal to -1. So if I write down my range, let's look at what not that guy Kex said. Said y is an element of -1 to infinity. Okay, so if the asymptote truly is y is equal to -1, when we say -1 square brackets, what do we mean about this -1? Does the function exist at -1? Meaning, do we include -1? That's the question that I have for all of you in the live. Okay, and yes, of course, if we're saying to infinity, no, definitely, because to infinity means above the asymptote. But the question is, do we include this -1? Okay, goodbye, Aura. Do we include this -1, guys? Yes, not that guy, Kex. You were including it, but do we include it? Okay, don't worry, not that guy. I hopefully you don't get a heartbreak. Because we're here to learn, right? And as we learn, what happens is we become better, right? For having learned something. So yes, not that guy. Y is an element of -1 to infinity. We do not include the -1. So you were definitely close. All right. You were definitely on the money there, not that guy. I think you pretty much got the concept. You understood that the range is from the bottom to the top. Okay, so from -1 to infinity, it's just that we don't include the -1. Okay, so this is one way of writing the range, or we could say y is greater than -1. That's also fine. Okay, so either way, you can either write the range in this way, or you can write the range in that way. Okay, are we together, guys? Okay, so what informs our range? We always look at the asymptote, the equation of the asymptote, all right? And then we need to also look at the value of a. If a is greater than 0, it means we are talking about the function being above the asymptote. But if a is a negative value, a is less than 0, then we know that that means the function is found below the asymptote. So we wouldn't be talking about y being above the asymptote. We'd be talking about y being below the asymptote. Wow, thank you so much, Meryl Pearl. Blah, 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 blah. Blah, 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 blah. Back to you. Blah, 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 blah. Meryl Pearl. You are indeed a pearl. Thank you so much for your comment in the comment section, Meryl Pearl. I think you are you're a phenomenal person. You're an amazing being. Thank you so much for caring to comment in the comment section with your blah 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 blah. It's important because it's in the syllabus for the kids in grade 10, and they are writing it. So that's why, and it counts for marks. It has a reasonable amount of marks in the papers that they write, and it helps them get through the stages in high school, given that they are interested in actually getting through the high school phase so that they can go on to the tertiary phase and do something that can be of significance to their careers in some future point in time. So that's why it's important, so let's go and now check. So we've written down the range of the function, so hopefully that makes sense. Now let's go and check out 7.1.3. It says at the point g minus 2, okay, at the point g minus 2, the graphs of f and g intersect. Do we understand what this means? At the point g minus 2. Can you for a moment just try and talk to what this means? When they say at the point g minus 2, what is this, guys? What in the world is this? At the point g minus 2. What is this minus 2? And why is it standing within a bracket? What does it represent? Okay. What is g first and foremost? Let's just look at this. What is g? G is what? What does this represent? The g here. Okay, so let's look at this. What is g? Okay, g is the function, this exponential function. Remember, g of x is this specific function. And remember, we actually spoke about this function. We even got the function g of x is equal to 2, all right, half to the power x minus 1. So this is just a representation. G is standing for our exponential function. We are referring to the exponential function. Then when we actually now write g minus 2, what does that mean? It means in the place of x, we substitute negative 2. Okay. In the place of x, we substitute minus 2, all right, in the place of x. So in other words, when x is equal to negative 2, we want to understand that when we substitute in the place of x, we substitute this minus 2, we want to understand what is the y value, all right? What is the corresponding y value that we get when we substitute x as negative 2, okay? Yeah, so by substituting the negative 2, we get the y value of the graph. So not like x, you're not too far off. Definitely, indeed. When we substitute x is equal to negative 2, there is a corresponding value of y that we will get when we substitute negative 2. So let's just read this again. It says, at the point g minus 2, the graphs of f and g intersect. What does this word mean? Intersect. Okay, so this is where two graphs meet. Where they meet, they crisscross each other. Where two graphs meet, it's like where they touch each other, right? F and G. Okay, where they cross each other. So at the point g minus 2, the graphs of f and g intersects. Now they are saying determine the coordinates. Okay, yes, thank you, not that guy X. Okay, the point at which they touch and they are equal at that point. That's where they intersect. Where two graphs meet, I like what not that guy is saying in the comment section. Where two graphs meet, the point at which they touch, where they are equal. We say that's where the two functions are exactly equal. Now they're saying determine the coordinates of this point of intersection. So that point, as not that guy said, that point where they touch, where they are equal, we call that point the point of intersection. And typically we usually say f of x is equal to g of x at that specific point. And that's what's unique about a point of intersection. F of x is exactly equal to g of x at that point of intersection. So now here we are told at the point g minus 2. Remember, what did I say g minus 2 means? It means where the function g is represented, we replace x with negative 2. So remember, we are asked to find what? Determine the coordinates of this point of intersection. Now guys, coordinates are simply ordered pairs. Okay, coordinates are what make up a point. They're asking us here to basically find the coordinates of this particular point. What point? The point of intersection. The point of intersection. The point where the two functions cut, meet, have a joining, and they are equal. So already they have told us what the x value is. Okay, they said g of negative 2. Remember, what did I say is replacing this x? It is negative 2. That means our x value already we know is negative 2. Now what we need now is the y value, the corresponding y value. How are we going to do that? Get that? We are going to take g of negative 2 and we are going to come to this function and we are going to substitute negative 2 in the place of x. In the place of x, we substitute negative 2. So we've already done that, substituting negative 2 in the place of x. It's like we are giving this g of x an instruction. Hey x, take negative 2, will you? And then the function says, yes, thank you so much for giving me negative 2. I will now transfer your order through and substitute in the place of negative 2 on the right. So let's rewrite this. 2 half. In the place of x there, we are going to write negative 2 minus 1. And guys, really and truly at this point, what you can do is you can just grab your calculator and you can substitute all of this and just get your answer. Okay, so what I'm gonna do, all right, is I'm gonna do exactly that. I'm gonna write 2, okay, and then we are going to write our extremely amazing bracket and then write 1 over 2, then our bracket there, and then let's say shift there and try and get our exponent. Let's see, how do we get an exponent there? There it is, there it is, there it is. Okay, then we're going to write negative 2 You see that, guys? And then make sure that we write the -1 as it is represented. So there, what we have there now is now beautifully written into my calculator. And all I do is I say equal and then booyaka. Do you see? I get 7. I get 7. So that means g of -2 gives me an amazing value of 7. So that means my y value, my corresponding y value, right? If I'm going to write now my point of intersection, POI, P point O of intersection I, that point of intersection is -2, that's my x coordinate, and then my y coordinate is 7. Booyaka! There we have it. That wasn't too difficult now, was it? Guys, this is an amazing 3 marks that you just get for making sure that you are able to get the point of intersection where 2 graphs meet, where they touch, where they are exactly equal. All right, because we were told specifically that g of -2. Okay, so we read this as g of -2. Okay, we're told that at the point g of -2, the graphs of f and g do what? Intersect. Determine the coordinates of this point of intersection. Okay, and all we need to do, since we have the function of g of x already, remember we have the function g of x equal to 2 into half to the power x minus 1. All we did is we substitute in the place of x -2. We then replace the x in our expression function -2. We use our calculator. Calculator just nicely substitute. We get 7. There it is. So then that's our coordinates. Coordinates are -2 and 7. Okay. All right. No. We don't have to. Okay. All right. Because if we did, we're still going to get the same value. All right. I mean, you can check that out. Remember, for f, okay. Remember, guys, that this x value, they are saying at the point g -2, the graphs of f and g intersect. So remember, -2 applies for the function g, -2 also applies for the graph of f. But for us to substitute in the graph of g is enough for us to get the point of intersection. We don't have to go through the trouble of actually doing it with the graph of f as well. But even if we did it with the graph of f, let's see, guys, you want to check? This is f, right, of x, right? So f of x is here, right? I'm just doing this so that you guys can see that you don't have to do it for both, because remember that x value, that's -2, is the same x value that will be there for f. All right, so substituting it to g alone is enough, but you want to check and verify for yourself that you still get the value 7 when you substitute -2 for f of x. Please go ahead and be my guest so we can check that out. F of -2 is equal to 3. Remember, in the place of x, remember we have -3 into x in the place of x now, because we've given the function f an instruction, receive -2 for x. So replace -2 for x in the function, and then there's that +1. So what do you see? -3 times 2 gives you 6, that's positive, +1, we get 7. So do you see that either way you still get your coordinates as -2 and 7? Why is that the case? Why do we still get the same value as our output? It's because, remember, guys, this is the point of intersection of f and g. Where these two functions meet, we are expecting that indeed the points should be the same. Okay? Should be exactly the same. Yes, they should be. Okay, but like I said, for the purpose of answering this question, you wouldn't have to go through the trouble of substituting at the function of f. It's enough to substitute in the function of g, because you know the answer that you get here represents the answer you would get even for f without having to even substitute. Why? Because you are told At the point g negative 2, the graphs of f and g intersect. Determine the coordinates of this point of intersection. You are told that they intersect. It's not like they are saying check if they do. They are saying they do intersect. Whereas maybe a different question would have been that at the point g negative 2, do the graphs of f and g intersect? That would be a question. So then what you would do is you would substitute negative 2 for g, check, do you get the same y value? Do you get what do you get? And then you take the same negative 2 and you go and substitute it into f and check, do you get the same value? If you do, then you would conclude that, oh, indeed, f and g do intersect. But imagine if you substitute a negative 2 here and you didn't get the same y value, then it would mean that these 2 points don't intersect. Are you with me? They don't intersect. But the only reason why we can confirm and verify, even though we were told explicitly that they do intersect, but we can also confirm that because you can see that the coordinates are the same. Okay. I hope you guys are feeling this, guys. I hope you are feeling this and it's making sense, all right? I need you guys to walk off here feeling a little bit more buff and strong to tackle functions, because functions, they are becoming a pain for some people, but they don't have to be. Okay, let's look at this last question for this particular question. The graph of G is reflected about the x-axis. Now, very keyword here, reflection. What in the world? Reflection. The graph of G is reflected about the x-axis and then translated 3 units down to form the graph of H. Please take note, I'm gonna reread this. Let's take it slow this time. The graph of G, right? By now, guys, the graph of G should be very much known by you now, right? G of x is equal to 2 half to the power x minus 1. Okay, even though there's no question that asked me to sketch this function, I already have a visual image of this function in my head. I see a function that is above the asymptote because I see my a is positive, it's positive 2, so my function is above the asymptote. And since my b is a value that's between 0 and 1, I can see that this is a decreasing function. It's a decreasing function, guys, you know, but it's above the asymptote, which asymptote is y is equal to negative 1. Like I can see, like in my head, I have a visual image already. Why do I have a visual image? It's because I understand a, my b, and my q. You see, when I know these things, guys, it's life is, it just begins with the exponential functions and I have no problem. Now, this is a concept now that we are getting exposed to. It says the graph of G is what? Reflected about the x-axis. Come on, guys, in the comment section, I want to hear from you. What do you understand about reflection about the x-axis? What do you understand about a reflection about the x-axis? What do you guys understand? Okay, not that Gygax says the y values become negative. Okay, the y values become negative. Okay, I hear you. Not that Gygax. Are we all getting the same understanding as what not that guy is saying? Not that guy is saying that the y values become negative. Okay, Sitlelusi is saying yes, sir, we are understanding. Guys, this is a very important concept here. A reflection about the x-axis. Mind you, same thing, same difference. Reflection about the line y is equal to 0. Okay. Beautiful Makoma. Makoma, you are coming here to Makoma, the kids' meal. Okay. A reflection about the line y is equal to 0. Okay. So yes, there's a change in y. Even with what Makoma has written there in the comment section, you can see the x values from from x and y, those coordinates, to x negative y. So what's changing here? It's the y values. I think what's fundamental here, guys, is to understand that there's a change in the y values. There's a change in the sign of the y values. That's what fundamentally reflection about the x-axis means. Now we need to be a bit more practical about this. Okay, so imagine that this is the x-axis. Okay, now if you are let's say for instance you have this function like this, right? Okay, let's say this is the function. If you are reflecting this function about the x-axis, okay, we need to understand what we are doing. You know, it's like a mirror image of this function. You are seeing a mirror image of this function. Okay, a mirror image. You're seeing a mirror image along this axis. Okay, and what basically happens is that what changes here, if you look at the y values here at the moment, okay, the y values here are negative. But the minute you reflect this function along this x-axis, what's happening now when we have this function that's reflected? These y values for this function are actually now what? Positive. Okay. But you will observe something about the x values. The x values don't change. Okay. So I need you to understand that when we say reflection in the x-axis or about the x-axis, which can be rephrased as the line y is equal to 0, because sometimes people get confused. We say reflection along the line y is equal to 0. You know, if you say reflection along the line y is equal to 0, remember the line y is equal to 0 is the x-axis. Okay, so this is the same concept, and we need to understand this thing here, that when we are reflecting in the x-axis or the line y is equal to 0, it simply means our y values are changing. That's what's changing. The y values change, but x values don't. Okay, so that is why this comment here, I'm just gonna let's do this, let's pin this comment. Oh, okay, I don't have such privileges yet. No, it's fine. Yeah, still young, eh? This channel is still young. So all in all, I hope you understand. Okay, that's a reflection in the x-axis. Let's never forget about reflection in the x-axis. So let's go back here. They are saying the graph of G is reflected about the x-axis, right? So in your head, immediately, it should say something to you about the function of what? Of G. What's changing there? Hey, what is changing there? Then secondly, they say after that, it is then translated. Translated. What does this word mean now? Translated. Okay, translated. Can anyone come up with a synonym or something that means something similar? Maybe this word is a bit, it loses some people. But what does translated mean? Do you understand what translation means? Yeah, say yes, when you are the best. Moving something. Yes, movement. Movement. Now we can either move vertically, that's very important. We can either move vertically or we can move horizontally. But in grade 10, guys, our movement is limited to vertically, right? We will look at horizontal movement only in grade 11, but in grade 10, we have limitations in the movement because you guys are still learning functions, bite-sized, small, slowly but surely you are getting there. So when they say translated, 3 units, look at it, 3 units what? Down. 3 units down. So we're talking about downward movement here. And what does all of these changes lead to? It leads to the formation of the graph of what? Of H. Hey, I hope you guys are seeing this. Hey, I hope you are seeing this. All right. So they are saying determine the equation of the newly formed graph. Okay. So I repeat, the graph of G is reflected about the x-axis, or in other words, the line y is equal to 0. Please, guys, understand these interchangeably. Okay. No problem, Lerato. I'll be posting it up. Don't worry. Please do go and study for Sebedi. Guys, please don't sabotage yourself and be here in this live session, but you are studying for something tomorrow that you are writing, which is important. And remember, we need to balance those marks. We don't want to just be skewed to a certain direction with the maths marks and they are too much, but then everything else is imbalancing. Please, Lerato, I want that Sebedi to be level 7 and more. Hey? So you better get down to it. Okay, so I repeat, the graph of G is reflected about the line y is equal to 0. So I think we understand what reflection about the x-axis means now. Okay, we are changing y, right? And then translated 3 units down. So when we are moving something down, what does that mean? Okay, we are moving it down, right? It means that we are somehow affecting the range of the function. Remember, because range has something to do with from the bottom to the top. Okay, so when we are moving down, it means that our Q value here, we are actually subtracting something from the Q value because we are moving down. But if we were moving up, we would not subtract something from the Q value, we would add something to the Q value. Okay, does that make sense, guys? I hope it makes sense. All right. Okay, I hope we are clear for the grade 10s. No, this is grade 10, guys. Grade 10 grade 10 functions. Okay, this live session is for the grade 10, but obviously if you are in grade 11 and you are listening to this, there are benefits in certain aspects. Okay, so remember this here, this negative one represents, what did we say earlier on? Okay, this negative one represents the horizontal asymptote. Okay, and its y is equal to what? Negative 1. This is a horizontal line. But remember, if we are saying we are going to be translating the function, how many units? 3 units down. That means, what are we doing to the horizontal asymptote? We are going to move it down. If we are moving it down, that's how the function will also move down. Does that make sense? So we are going to do what when we are moving down? When we are moving down, we are subtracting 3. From who? From g of x. Okay? So let's now try and get into this understanding of, because remember, what did they say? They said that we need to determine the equation of the newly formed graph H. H is a newly formed graph. So we want to find the newly formed graph. Yes, not that guy. We need to do things in order. Okay, reflection comes before translation. Reflection comes before translation, not the other way around. And this has to do with what? Why do we say reflection comes before translation? It's because BEDMAS as well, there's an order when we are dealing with BODMAS or BEDMAS. Brackets, exponents, division, multiplication. Multiplication, okay, has to do with reflection, okay, which comes before what? Addition and subtraction, in that order. So reflection, multiplication, then translation, addition if you are moving up, subtraction if you are moving down. Hey, that's why we don't translate first, then reflect. But what do? We reflect, then translate. So h of x is equal to negative g of x minus 3. Hey, please look at this, guys. H of x is equal to negative g of x minus 3. Remember, g stands for y. So there's a change in y, all right, for reflection. Hey, guys, reflection in x-axis. This year, translation 3 units down. Okay, I hope it makes sense, guys. I hope we are together here. I hope Sihamba song and no one is salarying, hey? Okay, so reflection in the x-axis, change of y, g of x. Then translation 3 units down, we subtract 3. Okay, now check. Okay, I'm wanting h of x, wanting h of x. So now, in the place of g of x, there's this negative, remember, 2 half to the power x minus 1 minus 3. Hey, take note, guys, take note. Do you see that in the place of g of x, I've just replaced the entire g of x with the function 2 times half to the power x minus 1 in the place of g of x with the negative sign multiplied with this. Then check what I'm going to do. Negative 3 is waiting outside, obviously, because it's minus the 3. So let's do this. Minus 3 times, negative times this first term, because inside this bracket there are 1, there's 2 terms. So take this negative 1, distribute it there. Take this negative 1, distribute it there. Okay, so negative times this gives me negative 2 half to the power x. Okay, I hope we are together. I hope Sihamba song, okay? Then this negative times negative 1 gives me positive 1. By distributing the negative sign, I've just removed the entire bracket. And then that subtraction of 3 is now ready to have its fair share of this like term, that's positive 1. So our final answer, so that we have the function of h of x, is the following. Negative 2 half to the power x. What's 1 minus 3, guys? It is negative 2. Ha. How many marks? 3 marks. How did it go? Very well. Understand now why reflection needs to come before translation? I hope you understand very well. What would have been the danger had we gone ahead and done the translation first and then done the reflection? We would have not gotten this function as accurate as we now find it to be. So please, guys, take note of what I've just done. Any questions in the comment section? Any questions, guys? Any questions at all? That's the function of h of x. The equation of the newly formed graph h of x. It's negative 2, brackets half to the power x minus 2. Done and dusted. Diputso? Questions? Efra? Mibuzo? Anything? Near. You're doing Afrikaans, not that guy cakes. Okay, alright, guys. If there's no questions, then I hope that's very clear for all to have beholden. Okay, I hope that's very clear for everyone. good, and we are good, and we are very good. Okay. No questions whatsoever. No questions whatsoever. No questions whatsoever. None at all. Okay, let's see if I can't get another function. Let's see. Okay, this looks appetizing. Here's another one, guys. Here's another beautiful one. Given f of x is equal to 3 to the power x minus 1 and g of x is equal to 1 over x plus 1. Sketch the graphs of f and g on the same set of x's using the provided diagram sheet. Okay, I don't have a provided diagram sheet, so this will have to be freehand. Clearly indicate all intercept points with the x-axis and the y-axis, as well as any asymptotes. Okay, so what function is this, guys? What type of function is this? Do we know? F of x. Yes, it's exponential. Thank you to that guy. And this one? This function? What shame. I think not that guy is the only one now who's participating. G of x? I can just see you thumping away there trying to type. Okay, let's be very careful. This is not a parabola, or in other words, it's not a quadratic function, because remember, parabola and quadratic are the same sort of type of function. So yes, this is your hyperbola. Please, guys, let's see things when they are hyper. Now sketch the graphs of f and g. F is the exponential function, g is the hyperbola function. We need to sketch these functions, and they're asking us to sketch the graphs of f and g on the same set of x's, so we need to represent them in the same set. And they're saying using the provided diagram sheet, which we don't have. Clearly indicate all intercept points with the x-axis and the y-axis, as well as any asymptotes. How many marks is it? Beautiful, 6 marks. So let's settle in and try and get the representation of this function. Right, it's not gonna be perfect, guys, but I just want to give us a clear sort of like indication of what we are dealing with here. So first and foremost, let's just look at the two functions we have for sketching purposes. 3 to the power x, this is minus 1. Okay, then let's plan. Very important to plan. So 1, what is the a value? Okay, the a value is unseen. It is actually equal to 1. Okay, it's unseen. There's an invisible 1 here. 1 times 3. That a, guys, is actually equal to 1, which means a is greater than 0, which means, in other words, the function will be found above the asymptote. And b, since b is actually greater than 1, it also means that it's going to be above and increasing. So in my head, already I can see the exponential function being above the asymptote, increasing in this direction. Okay, then 2. What do I need to get? I need to find my x-intercept. Remember, how do we get, how could I even forget? Before you even write your x-intercept, we know that a exponential function has a horizontal asymptote. Okay, so that is the second thing that must come after assessing a and b. A is greater than 1, a is greater than 0, so that is my rough sort of like anticipated shape. I begin with the end in mind. Okay, because b is greater than 1 as well, I know it's an increasing function, it's above the asymptote. Horizontal asymptote, what is it? Remember the Q value. Okay, so my horizontal asymptote, the equation is y is equal to -1. Very important to always indicate your horizontal asymptote. So I'm just going to come here, -1, and I'm going to sketch that in. Okay, my horizontal asymptote, and I'll immediately label it y is equal to -1. There's a mark in doing this, guys. Just a mark for drawing in your asymptote. There's only one asymptote for your exponential function, all right, and it's always represented by your Q value. Now we can move on to our x-intercepts and y-intercept. X-intercept, we know that we let y be equal to 0 in the function. So there we have it. We're going to say 0 is equal to 3 to the power x minus 1. We take the -1, we transpose it. It's 1 is equal to 3 to the power x. We change that 1 to 3 to the power 0, because remember, any base raised to the power 0 is actually equal to 1. That's equal to 3 to the power x. The bases are the same on either side of the equal sign, so therefore we conclude x is equal to 0. Okay, so that is our x-intercept. Our x-intercept is that when we let y be equal to 0, our x is also equal to 0. So that means we have a x-intercept of 0, 0. All right, and it seems like our y-intercept will not be any different, because if we are going to let x be equal to 0, what are we going to get as a corresponding y value? We are also going to get y being also equal to 0. Because remember, if y is equal to 0 gives us x is equal to 0, it means if we substitute x is equal to 0 for our y-intercept, we are still going to get y is equal to 0 as well. So that means our 0, 0, our 0, 0, okay, our 0, 0, guys, is actually going to be it's going to be the x and the y-intercept. Okay, let me just do it so that people can be content. So let's say y-intercept, we let x be equal to 0. So let's do that. I'm going to say y is equal to 3 to the power, in the place of x we write 0 minus 1. That's my 1 minus 1. And that's y is equal to 0. So that means, again, we have our x-intercept and our y-intercept giving us the same coordinates. Okay, same coordinates. So I can mark that point. I can mark that point so that I have it for my graph. Okay, now when the situation, guys, is like this, all right, it's very important that we then try and get at least, let's at least try and get one value this side that's positive and one value this side that's negative. Why do we do that? It's because we want to see the shape of the function. Okay, so what we then do is we take any arbitrary point. So I like looking at 1 and -1, especially if, like, let's say I like looking at 1 and -1. So let's go to the function. If we substitute 1 here, 3 to the power 1 gives us 3. What's 3 minus 1? It's 2. Okay, so that means when I substitute f1 into the function, I get 2. So that means 1 and 2 is a point that is on the function. So I'm going to say when x is 1, y is 2. Okay, so that's a point that I have that I can actually use when I sketch. Then let's just check this one as well, -1. If you substitute -1, let's say f -1. So you can use your calculator to get these things quickly. You don't have to necessarily write them out. Okay, it makes life easier that way. 1 over 3 minus 1, that gives us -2 over 3, which is actually 0.6. If you actually go and work it out. So that means we get, when x is -1, y is -2 over 3, which is -0.6. So let's come here. When x is -1, y is equal to 0.6, -0.6. So let's say that's here somewhere tentatively. So where do these two meet? They meet exactly there. Now I can take your pencil, right? Please, guys, sketch using a pencil. You can then sketch through these points, you see? right? And there it is. And then these additional points, I just mark them. Okay, so it's -1 and 2/3. So there it is. That's my sketch, my function, and then I just label it f of x. You see? So that's my exponential function. That's for f of x is equal to 3 to the power x minus 1. But remember, guys, we're supposed to sketch two functions on my Cartesian plane. I also need to include the hyperbola, right? And the hyperbola there is actually 1 over x plus 1. Now the thing is, guys, very sorry, very sorry here. This function is actually not a grade 10 function, it's a grade 11 function. Okay, so I'm just gonna have to hold it there for my beautiful grade grade 10s, because this is grade 11. All right, so this is your hyperbola function in grade 11. Okay, for grade 10, okay, let's just say the two functions. Let's say g of x, let's take it that it was 2 over x plus 1. Okay, so let's just improvise here, because remember the grade 10 hyperbola function never ever will have a binomial expression in your denominator. Your grade 10 hyperbola function always has a single x variable in your denominator. That's because there are certain limitations of how much we are anticipating to learn as grade 10 learners. So I'm just going to improvise and sketch the function of 2 over x plus 1 instead of sketching the function of 1 over x plus 1 in the denominator and sketching that. So let's look at a function like this, 2 over x plus 1. How would we sketch this function? So once again, we plan first and foremost. 1, the numerator value, which is a, is actually equal to 2, which means a is greater than 0. Now for a hyperbola in grade 10, whenever a is positive, we know that our function can be anticipated to be found. The hyperbola function has two arms. One will be found in the first quadrant, and the other one will be found in the third quadrant. So this is like the odd number quadrants when a is positive. That's where we start. We start by figuring out, because of a, which shape and position of the function do we have. Okay, so I hope that makes sense, guys. So if a is equal to 2, meaning when a is greater than 0, then we know that our hyperbola function is found in the first and the third quadrant. Okay, and in the first and the third quadrant, that's where we are supposed to actually locate the function. If a was not greater than 0, if a was less than 0, then we know that we would find the function in the even number quadrants, which means it would be found in the second and the fourth quadrant. Now let's remember that for our grade 10 syllabus, this is the y-axis, which is the line x is equal to 0 for our grade 10s. This is grade 10, guys. Okay, so this is our vertical asymptote, x is equal to 0, and then your horizontal asymptote will be given by the what? It will be given by the q value. So that will be y is equal to 1. All right, so that's what we are expecting when we do sketch. Okay, then 2, we write in our vertical asymptote and our horizontal asymptote. So what is our vertical asymptote? First and foremost, we know that because of the denominator x, we know that our vertical asymptote in grade 10 is always x is equal to 0. In grade 10, guys, because of our restrictions of the function, we know that the vertical asymptote is x is equal to 0, and that's always the case if you are a grade 10 learner. Okay, until we change things up in grade 11 when we have a binomial expression in the denominator for x. For now, we still have a single variable x, which is why we say our vertical asymptote is x is equal to 0, because we can't have the denominator here being 0. The function is not defined on the asymptote. Then lastly, our horizontal asymptote, the q value as it is, the horizontal asymptote is y is equal to 1. All right, Okay, are we together, guys, so far? Please let me know if I'm too fast, I'm losing you, you are not with me, you are lost. It's so great, and this is very important for your hyperbola function sketching. You have to be able to firstly speak about the a value, what does it mean, and what does it basically mean about our shape. Then we have to then look at the vertical and the horizontal asymptote. Vertical asymptote, remember that denominator of the fraction, single variable x, means x cannot be 0, which means our vertical asymptote is x is equal to 0. And then our horizontal asymptote always given by the value of the q value, which is, in this case, y is equal to 1. Then we know from there we write the x-intercept. So we let y be equal to 0. We only find the x-intercept for our grade 10 hyperbola function. We don't bother ourselves and find the y-intercept. Why? Because we know that the function will not cut through or touch the y-axis, because we know that the function there is not defined. So we don't waste our time and say let x be equal to 0, because we know that will not yield an answer. So let's look at this and let's solve for the unknown. So we transpose the 1, becomes -1 on the left hand side. Then we look at the equation. We have a variable in the denominator, which means our LCD is x, our restriction is x cannot be 0. We then multiply both sides in the numerator by x, which means we'll get a negative x here this side, and we'll get a positive 2 this side, and then we get a final answer because we divide by -1 both sides. X is equal to -2, and our coordinates of the x-intercept are -2 and 0. Okay, so let's go there, okay, and draw in the asymptote. So firstly, remember, horizontal asymptote, y is equal to 1. Just for that hyperbola, this function won't, the hyperbola function won't touch this asymptote. Very important, this one. Remember, this asymptote is for the exponential function. Okay, but this asymptote is not for the exponential function. Hence, you can see the exponential function passing through this asymptote. This asymptote, though, is for the hyperbola, and there is no way that the hyperbola will dare pass through these boundary lines. Okay, so let's go. Let's first go and draw in our asymptote. So we have y is equal to 1. There it is. Then our function is found in the first and the third quadrant. Okay, first and the third quadrant. Okay, so let's go there. Let's just check. We have the coordinates -2 and 0. So let's go and locate this -2 and 0. That's there. All right, and then what we can do is we can just, because we want to find out a point where the function passes through here in this quadrant, we're just going to choose 2 values of x here, 1 and 2, and we're going to substitute them into the function. So if we take 1, for instance, and substitute in the place of x, what's 2 divided by 1? It's 2. 2 plus 1 is 3. Okay, so that means when x is 1, y is 3. Okay, then last but not least, let's take 2 and substitute into the function. 2 divided by 2 is 1. 1 plus 1 is 2. So when the x is 2, y is 2. Okay, so if we sketch then the shape passing through, right? Hope you can see that arm there. Okay, then last but not least, let's check out here. We know we have this point, which was basically the -2 and 0 that we found for the x-intercept. Let's try and find another value so that we can see the shape. So let's just check when x is equal to -1. If we substitute here, 2 divided by -1, 2 divided by -1 gives us -2. And then -2 plus 1 gives you -1. Okay, So that means when x is equal to -1, y is equal to -1. So what we can then do here is just pass through these points. Okay, and let's just make sure we don't touch the horizontal line. Okay, so guys, I hope you can see the two functions represented on the same Cartesian plane. Okay, not too bad, was it, guys? Not too shabby at all. So let's just label this function. This becomes g of x. Okay, remember that's 1 and 3. Okay, for this point, that was 1 and 2. Sorry, 1 and 3, that's 2 and 2. Sorry, I said 1 and 2. This is 2 and 2. Okay, so that was 1 and 3, that's 2 and 2. This one was -2 and 0, and then that point was -1 and 1. And -1, sorry. Okay, marked, labeled. Shapes are beautiful to die for. Just amazing, amazing, amazing. Okay, not too bad, eh? Not too shabby. Guys, not too shabby, not too shabby. Now, let's check if people can tell me what is the range of f of x. Let's see if in the comment section you guys can actually help me out there. What is the range of f of x? Remember, f of x is the exponential function. What is the range, guys? What is the range? Let's see in the comment section if you can help me out. What is the range of the exponential function? What's the range of f? Remember, range is the possible y values where the function exists. So what is the range of this function? Okay, not that guy. Look at you. Woo! What I love this time around as well is the fact that your brackets are powerful. You see, not that guy. Hence I was saying to you earlier on that it's fine to make errors, right? We make errors to make a glorious comeback. If we don't write the range this way, we could always write the range what way? We can say y is greater than -1. If you don't want to write your range this way, you can write your range this way in inequality form. Because remember, the function is above the horizontal asymptote. Okay, so either way, you must decide, And I think it's nice when people decide and they stick to a certain way of doing things so that you always have uniformity in doing things, same way all the time, right? Let's look at the range of g. What about the range of g of x? What is the range of g of x? What is the range of g of x? Range of g of x? Range of g of x? Remember, it's the hyperbola. Range of g of x. Okay, so you can see that this function of g exists. It exists below the asymptote, which is y is equal to 1, but it also exists above the asymptote, which is y is equal to 1. So what would we say then is the range? Not that guy, not quite, not quite. Not quite. So what you've just written down as your answer represents the arm that is above the asymptote. But what about this one that's below the asymptote? Because remember, your hyperbola function has two arms. There's one that's above the asymptote and there's one that's below. Okay? And if you are saying from -infinity to infinity, the question is, you are saying then obviously 1 is there, because everything between -infinity and infinity actually includes the value of 1. So does that then mean that the function does exist on this line? Does that mean that? Is it true? No. Okay, so that's why it's very important. You can say this, right? But then there's a restriction. Y cannot be positive 1. So sometimes they don't even write it like this, but they write it like this. Y is an element of R. Y cannot be 1. Okay, you choose. Both ways are acceptable. You can write your range this way, meaning for all y values, the function does exist. It's just one exception. This is like one exception. And the exception, guys, is the horizontal asymptote. Okay, so please take note of how we write the range of a hyperbola as opposed to writing the range of an exponential function. Remember, a hyperbola exists below and above an asymptote if it is not stipulated otherwise, or we are told that there's a limitation. Because sometimes they will tell you that the function of the hyperbola exists where x is greater than 0. Now, if you're going to say it exists where x is greater than 0, it means that it will exist above the asymptote, but this is not x is greater than 0. This side is x is less than 0, so it wouldn't exist below the asymptote. Okay, because where x is greater than 0 is basically below the asymptote, and that's where the function exists, but it doesn't exist anywhere on the vertical asymptote, right? But then it continues to exist on this side of the vertical asymptote. So it's very important to note that. All right, guys. Lastly, what about domain and range? I think I'm going to hold it right there for today. Domain and range. I mean, range we've spoken about. But what would be the domain of the exponential function? So the exponential function is here. What would you say the domain is? Possible x values where the function exists. Domain of the exponential function is what? Thank you, not that guy. I guess you're the only one that's here, hey? Yes, that's what it is. That's exactly what it is. Okay? Or you could say x is an element of R. Very good. Either way. Okay, so please take note of the domain of the exponential function. And then what's the domain of the hyperbola function? Remember, this function exists everywhere for x except, and then it exists again, right? So there's an exception for the domain as well. So what would be the domain of the hyperbola function? And then we can call it a night, guys. I have to go and sleep myself because I have an early morning. Domain. Domain. Thank you, not that guy. X is an element of R. X is not equal to 0. You've got it. Okay, my guy, I think you're good. Let me absolutely love and leave you. Yeah, so if they had asked conclusion, write down the equations of the asymptotes. So for the exponential function, the equation would be, and then for the hyperbola functions, the asymptotes or the equation of the asymptotes would be, and also the vertical one, which is, okay, so let's not forget that, okay? Let's not forget those. Okay, guys, there's more sweet, amazing interpretation questions where functions are concerned. You know, we can always look at that at a future live. But thank you so much. It was good. I unfortunately cannot continue any further, but it was good. Thank you so much, not that guy. You were really a great sport in the live. Those who had joined in earlier on, before bedtime had actually started. Hopefully that was a beneficial session. You guys thoroughly enjoyed that, and it was worth people's time. I really hope so. I aim to make a difference, because maths is a game. It's easy. 100% is not a foreign affair, guys. I, as your Minister of Maths Affairs in the Maths is a Game platform, I'm saying to you, and I'm saying again and again, that 100%, scoring of 100% in mathematics, in whatever term, is not a foreign concept. It's something that learners can do. Let's just understand the maths, play the game very well, and just enjoy and have fun with it. Okay, thank you so much. I will see you again. Maths is a game. Let's continue playing until level 7s become the only game pieces that we have anything to do with. Okay. Can we start with analytical and you can join next week, because my school hasn't started with it? Really? Not that guy cakes. I hope you've been watching the videos, because I made some analytical geometry videos posted onto the YouTube channel. There's an actual segment, an entire segment that looks like introduction formula, the gradient formula, and then I'll just have to continue feeding in, but like a small snippet videos, they're not that long. So please do check it out, so that at least the analytical geometry you can get a little bit more from it. Then also there were a few videos I did on Euclidean geometry, just not at length, so I will actually get cracking with that too next week. But thank you so much for saying that. And if I don't make live sessions, I'll definitely make the time to make small segment videos and post them onto the YouTube channel, so that you guys can check those out at your own time and at will. Okay. Thank you, all those that were actually here. Letabo, thank you so much. Letabo for you all. Thank you for being here, not that guy. And Vilska, is it Vilska? Wake up to reality. Hopefully you have woke up to reality and you're good. Okay, right, bye.